So the domain modeling is also known as conceptual modeling, where through this domain modeling you will be trying to you can represent various concepts or objects that actually appear in your problem domain. So as well as it also captures the relationship between the identified objects or the objects that are appearing in your problem. So here, so we always try to consider only classes, but without without any methods and data. So only we try to represent classes here. Okay, during domain modeling. That means here we just try to identify what are the different entities mostly. So three types of objects are identified. So one is a boundary object, the other one is a entity objects, and there is a controller object. Okay. So boundary objects are the ones which are objects related to your user interface. That means they handle user interfaces, right? So let's say you talk about in Java programming language, if you going to create a label object, or you wanted to create a text area, so or you wanted to create a menu, so like there are certain Java classes are available, right? So J class, so J menu, J button, J radio button. So these sort of there are certain number of classes. By using using those classes, you create some graphical user interface objects, right? So they usually do not do any processing. Okay, so your boundary objects actually they do not do any sort of what do you say, processings. So entity objects corresponds to physical entities. That means whatever the physical entity is part of your system, so they will be represented through entity objects. And there are controller objects, so they are actually objects that are entirely conceptual. Okay, so these objects actually involved in processing, right? We will talk about them. So boundary objects with which the actors interact. That means, as I told you before also, so it's like a related to buttons, or it related to menus, or it related to the screens, forms, dialog buttons. Okay, so what objects you have. So with all those GUI objects, usually the actor or the user is going to interact, right? So through those objects only user is going to interact, right? That is the reason why. So those objects are actually the boundary objects. They do not perform processing, as I told you. Only they validate. Sometimes they do validation. Like let's say you have used a login page. You have created a login page, right? So sometimes you see if you are going to enter your let's say username as the email ID, email ID as the username, and you have some password, right? But if you have, let's say for example, you have entered a very invalid email ID, like you write something like this, XYZ something, you have written this much only. Now in that case what will happen? It will tell you that it's not a valid email. Okay, why? Why? Because your valid emails are like this. So XYZ @ something, and then dot, and then you have some domain name, right? Com, in, AC, this sort of, right? But if you do not follow those things, then it will tell you that they will validate that this is a invalid email. Sometimes it can tell you that it is invalid password. Okay, so they usually only do some processing, that is only validations, right? But actually they are not going to do the processings which are really required as part of your system. So they were earlier being called as the interface objects. Sometimes they are also called as interface objects. Okay, they are being the interfaces classes. These are the terms usually used in Java, and com, decom, and UML also, right? So the initial identification of boundary classes can be made by defining one boundary class per actor use case pair. Okay, so now how you can identify different boundary classes. So usually you can identify like this. So actor is interacting with a particular use case. Okay, for that you identify one boundary class. So like per each pair, so you identify boundary classes. That is the way that you will have to identify the boundary classes. Once if you identify the boundary classes, then also you can easily identify your boundary objects. So different categories of users have different privileges and different levels of familiarity. That is also you know, right? so so different users will have different privileges. That means they will be allowed to access certain number of use cases, right? And there is a entity update, entity objects, as I told you. So this only these are the physical entities. Okay, physical entities means something like so these are all, I mean real objects, because that holds some sort of information, right? So you can think of something like this. So hold information such as data tables, files, etc. Book is a physical entity. Okay, book register is a physical entity, right? So user actor who is going to interact with the system is also an entity, right? So whatever the entities, so usually they are entity objects, right? So let's say if you talk about any book, so usually this book entity will hold some information, right? What information may be like the author name, the author's author of that particular book, ISBN of that particular book, publisher of that book. So these are the certain informations associated with this particular class book. That means it holds some information, right? Maybe in terms of some data files or files, right? Database tables or files. So many of them are dumb servers. That means they are not doing much of the server activities. Only they are so just doing updating, storing data, fetching data, this sort of activities they do. Okay, so these are all entity objects. Now there is a controller objects. Okay, so this coordinate the activities of set of entity objects. Now as you identified, so as part of your system, so you will have so many entity objects, right? So now, so these are the objects. Actually, they actually coordinate various activities of these all different entity objects. They usually interface, they act as the interface with the boundary objects, right? So your boundary objects actually going to talk with the entity objects through your controller objects. Okay, so your boundary objects, so they will be talking to this controller objects, and then controller objects in turn going to talk with your entity objects. That means it is an interface with the boundary objects, right? So actually these controller objects, actually they realize a use case. Okay, so I told you, so they do carry many processings. So you have a use case means a lot of processings are really required, right? Some functionalities are there, right? So these are the objects actually do the processings. Okay, so embody most of the logic involved with the use case realization. So that means whatever the logic that really required to be developed as part of a particular, as part of the use case. So those things will be part of these objects, right? So there can be more than one controller, right? So it's not that only one controller, there can be many controller objects. Okay, so you can see the how you can realize a particular use case. You can see, as I told you, so there are certain entity objects, and these entity objects are related, right? And you have a controller objects and you have boundary objects. So there are two boundary objects, right? These are the, so now the controller object here acts as a interface, right? Now the boundary objects can directly talk to any of these entity objects through the controller object, right? So this is the way that you try to execute, or you can accomplish a particular, or you can realize a particular use case. Any doubts so far, students? Any doubts so far, students?
No, sir.
No, sir.
Okay. Right. So now there is this concept called class responsibility collaborators. Okay. So there are CRC cards. Okay. So now this is actually pioneered by Ward, Cunningham, and Kent Beck. Okay. So developing the interaction diagram for use cases may require participation of team of developers through the use of CRC diagrams, right? So whenever you wanted to develop any sort of interaction diagram for a use case, if that particular use case is very large or very more complex in nature, so usually you require many team of developers, so they will be taking part to develop a interaction diagram. So it's so sometimes the interaction diagram will be also very large because of the large use case, right? So now there is a concept of CRC card, class responsibility cards. Okay, so there it actually when you are going to develop these interaction diagrams, right, for a particular use case, and the use case is very complex in that case, so we will make use of CRC cards to develop the interaction diagram. So how it will happen now you can understand. So now the index cards prepared one each per class. So let's say you have a 10 class, so usually 10 index cards will be created. Okay, that means per each class there will be an index card created. Okay, index card means it is a sort of card you can think of, right? It's a small piece of card. Okay, so responsibility is written on these cards. Okay, so that means the responsibility assigned to that particular class is written on this particular card. That means what is the responsibility of that particular class, so that is mentioned in the index card. Okay, so responsibility of collaborating object is also written. I mean, because this particular class will be, I mean, the object of this particular class will be collaborating with other objects, as I told you. So there are certain number of objects, they will be interacting with each other to accomplish a particular task, or we realize a use case, right? So now then, so I mean, a class is collaborating with the other class, right? So that means, so there definitely there is a I mean, responsibility associated with the class A, as well as there is a responsibility associated with the class B, with which A is going to collaborate. Okay, so you can think of like this. So those responsibilities are written in this index card. Okay, now interaction diagrams are developed by flipping through CRC cards, right? Now what I'm saying here is you have all of these CRC cards. So each you have a CRC card per each class. Then that means you have a 10 classes. Then you have 10 CRC cards, and you will be flipping one CRC card after the other. Okay, and then you try to develop the interaction diagram. So this is the way that actually it will be helping you, right? So required for very complex use cases. Whenever you are going to develop the interaction diagram for complex use cases, then only these CRC cards are really required. Okay. So team members participate to determine responsibility of classes involved in the use case realization. Okay. So usually, as I told you, so all of the team members, they usually trying to participate to determine the responsibility of the classes involved in the use case realization. So they will be, so I mean, you can think of something like this. Okay, let's say you have a 10 team members. Okay, each one will be carrying out a index card, and in that index card it will be written that this particular class responsibility will be this. Okay, so that means that particular developer is going to develop that class with a responsibility of something, right? And now the other person, team member, he is also holding that particular index card and saying that I have my responsibility, but I need to get something, some some other responsibility from maybe the other class. Okay, so then he will be writing down, I mean, those as part of index cards it is written. So with which other classes this class is going to as well as so their responsibilities are mentioned in this particular card. Okay. Now you can think, you see here is a one example of a CRC card. So let's say there is a class called book register. Okay. So book register class will have certainly some responsibility. What are those responsibility? Find a book. Okay. So in a book register, you should always be trying to see a book, whether that book is there in that particular book register. I mean, there is an entry for that particular book or not. Okay. Or if you want to add a book into that particular book register, if you want to delete a book, so these are the responsibility. Means usually there are the so you can think of they are the methods, okay, or the functions, okay, of that particular class. Now, so when this particular responsibility, when you this particular class is going to handle this responsibility in collaboration with what? So this particular class has a responsibility of find book. Now it is going to collaborate with the other class, that is the book class. Okay, there is a book register and it is going to collaborate with the book class. So that means, so what do you have? So here you have the responsibility of this particular class, and the right side you have who are the collaborators. Okay, I mean with which other class. So this particular class is the, in order to execute, in order to achieve this responsibility, so with what other classes this class is going to collaborate. Okay, so this is what mentioned in the right side. So this is what I told you. Now you have these many number of index cards, right? And that is what I said you. So for each class, so you have index card, right? And that is what developed this way. Any doubts of our student?
Hello, sir.
Yes.
Sir, when you say team members, do you only refer to developers or business analysts are also included?
No, no, it's a developers means usually we are into the, mostly we are into the design part, right? Design. So you are your designers. I mean, the ones who will be going to code them, the code. Okay. Because here it is a class. Okay, so classes will be developed by whom? So here we do the designing, right? You have index cards and all. So now these designs will be converted into a piece of code, right? So some coder will come and so take up. So that means usually they are the developers now. Okay. Okay. Is it clear?
Yes, yes, sir.
So now I told you, so here is a very important topic under the software design is that, so design patterns. By seeing this patterns, you probably you can guess also, right? I mean, what kind of it would be, but yes, so this is actually originated in the field of architecture. Okay, where whenever that the architect, whenever they are going to develop or design very large buildings, so they try to take, they try to bring many of these pattern solutions. Okay, specific pattern solutions, right? They have small pattern solutions, and these pattern solutions are actually applied. Like me, you can think of, you're going to develop a very large building, right? So maybe it contains 10-story building. Okay, so then what you try to do, you have a patterns, like you have a pattern of developing 1 story, you have a pattern of developing 2 story, maybe you have a pattern of 3 story, right? So you will be keep on applying these all pattern solutions, right, to build a very large building, right? That means you have some smaller solutions for smaller modules, and then you have observed those patterns, right? And they are the best ones. They gave the best result in the past when you applied them, right? And then you bringing those things and developing the larger one. Okay, whenever you wanted to develop something larger, so you try to use those specific pattern solutions, right? So this is what exactly sometimes we get by experience, right? So the experienced designers, what they do, so they maybe they knowingly or unknowingly, So they try to reuse the best solutions that actually worked in the past. Okay. But so this is what exactly. So such reuse of design solution is systematized by the concept of patterns, right? So that now through the concept of patterns, what we are trying to do, we are trying to reuse the design solutions, whatever we identified. Okay, they have given the best result in the past, and those design solutions will be systematically applied now. Uh, when you are designing anything larger than that, or maybe you when you are designing something, designing a solution to a particular problem, where you can also, if you find some similar sort of patterns inside this particular problem also, then also you can apply them, right? This is what the idea. So that is what commonly accepted solution to be reused by everybody familiar with the pattern. Okay, so they always trying to reuse the best solutions. That is what we try to do. Patterns means we try to find some patterns, right? So here design patterns are commonly accepted solutions to some problems that reoccur during designing different applications, right? When you going through a different design, a different application, designing different application, where you can also see these sort of patterns. If you find that sort of pattern, then you know that for that particular pattern, if there is a existing solution, then you try to apply that. Okay, so this is the way that you can come up with any efficient design. Okay, you can come up with a very efficient design because you try to use the best practices. Okay, so use of it reduces the number of design iteration at the, it improves the quality and final design solution also. So as a result, so it also improves the quality of the design. And also, no need to go for multiple iterations, right? So multiple iterations, why you go for multiple design iterations? Because you certainly find that when you are designing something, right? So if you find that something you made mistake, so then again you try to make changes into the design, and you wanted to come up with the modified one. Durgesh, you want to ask? Durgesh, you want to ask something?
No, sir, no.
Okay. So this actually helps in reducing the number of design iterations. Okay. So it's a very something like this. If you have a very non-trivial problem, okay, usually a non-trivial problem consists of very large number of sub-problems, right? If you have a very difficult problem, in that case, what will happen? You have a very large number of sub-problems, also difficult sub-problems, right? And so usually when you solve, certain, if you solve some of these problems, right? Maybe you take any two problems, right? If you solve, then ultimately, there can be several sub problems also, right? Which can be common to these two problems. Okay, when you solve any two problems, right? So when you find the sub problems of these two problems, right? So there will be some common problems, right? Sub problems. Okay, they can be easily, they can be identified. Okay, and then if you have solution, if you have, let's say, if you have a solutions, right? I mean, if you have solution to those common problems, right? So they can be applied, or they can be repeated among different problems, right? That is what we try to identify. So this captures central idea behind patterns, right? So this is the way that we try to apply patterns, right? We always try to find some pattern problems, right? And to which, if you have any pattern solution, then we try to apply those solutions. So that is what idea behind these design patterns, right? So design patterns are well documented building blocks for software design. So they are very much well documented building blocks. So, and standard solution to commonly recurring problems, right? So usually you will always have a very standard solution, because some if you see the some common problems, right? And for which if you have a very non solution, then what will happen? Everybody will be using that particular solution, right? So that is what we are trying to say. Right. The basic idea behind patterns is that if you can master a few important patterns, you can easily spot them in application developments and effortlessly use the pattern solutions. Right. So once if you can understand certain number of patterns, then you will be able to understand. Okay. So you can find out those patterns within a particular problem, and then you can easily apply them. That is what. So first you need to know some of these patterns, right? Maybe we'll see through an example about one of the pattern, then you will be able to understand if you do not know as of now. Okay, so if patterns are really based on common sense, they what is point learning patterns. Okay, so as I told you, so usually so something that we have experienced in the past which have given us the best results means what? So it is our experience, right? It is our common sense, right? So if you have seen something better in the past, that means it is your common sense, right? And then why you need to learn these all patterns? If that is the common sense, then why you need to read? So this is you can think of, right? So it has been observed that while grappling with the nitty-gritty of complex design problems, okay, designer often forget the common sense. Okay, so because when you are completely involved, let's say you are completely involved in designing the solutions to the large complex design problems, right? So we often the designer often they forget many of these simple things. That is what happens. So that is the reason why we should know, we should learn, so we should identify so many of these patterns, and then only it will be easier for easy to you can apply them whenever it is really required. Okay. So that is what the problem, right? Because you always try to you always struggling with the complex design problems when you are thinking about the solution to those complex design problems. So you usually lose your common sense sometimes. So as a result, what will happen? You will not be able to apply them. Okay, you will not be able to apply them mostly. So as a result, so we may not be able to come up with the efficient design. That is what. So that is the reason why we should master all design patterns, and then we should always use them. So patterns are well documented building blocks for software design. So they standard solutions to commonly recurring problems. That is what I said you. So provides a good solution to model. So pattern has 4 important parts. So usually whenever you talk about any pattern, so it has 4 different parts. Okay. So what is that? So that means first you need to see that what is the problem. Okay. And then where this, within which context this particular problem occur. Okay, where this particular program occur, in which context it occur, and then what is the solution to that particular problem, and the solution within which, the context within which the solution work, and the context within which the solution would not work. Okay, so these are the 4 things that you should know about whenever you are talking about any pattern. Okay, pattern is nothing but it's a problem. Okay, so you have seen some problem for which so in within which context this particular problem is occurring, and what is the solution to that particular pattern, okay, or the problem. Okay, and where this let's say if you have a solution also, in what context this particular solution will work, and in which context this particular solution will not work. Okay, so these things should be known. Okay, so that is the reason why each and every pattern has these are 4 important parts. Okay, now there are different types of patterns. Okay, so very high designs termed as architectural design. Okay, so you know that. Okay, so very high level designs are called as architectural designs, right? And so pattern solutions have been defined for use in concrete designs, right? So usually our no these pattern solutions, whatever you have, we are going to identify now, okay, or we have identified these pattern solutions to the pattern problems, right? So, and they will be usually used in the concrete designs, not in the, what we are trying to say is not in the architectural design part mostly, okay. So patterns, there are patterns, so usually we apply at the architectural level and then at the design level, okay, and then then you have a idioms, okay, right. So is part of an architectural pattern, so it identify and provide solutions to the problems that are identified while carrying out architectural design. So you know that what is the architectural design, what is the software architecture, right? You trying to decompose your large problems into smaller problems by identifying different modules of it, right? So by identifying different modules of those large module, and then you trying to find sub modules, so those things you are carrying out as part of your architectural design, right? So these architectural design cannot be directly translated into a piece of code. That is what we have seen in the past, right? So the architectural design will be converted into a detailed design, okay? And the detailed design can be directly converted into a piece of code. That is what, right? So here your the patterns, whatever you are talking here, so they suggest a set of or a predefined subsystems, okay? So that actually specifies some of the responsibilities and includes rules and guidelines for organizing the relationship among them. That means, so it all says that here as part of architectural pattern. So it will all tell that what are the set of subsystems, okay, and their responsibilities, and some rules and guidelines for organizing the relationship between these subsystems, okay. So this is what exactly going to tell you here, this sort of pattern, okay. So they are actually really constructed for very large problems, okay. When so architectural patterns are being used when you have a very large problem, because you have large many number of modules, right, and you have a relationship between those modules, right, and you need to specify the responsibilities, and you need to have some certain rules, right? So which particular module should be talking to each other module, right? As I told you, there is something like this. So there is a one rule like this. So the higher level modules, so the lower level modules cannot invoke the higher level module. So this is one sort of rule, okay, or guidelines, right? So these sort of patterns, right? So that is what, if you find some patterns, pattern solutions, and that will be we are trying to apply at the architectural level. That is what we call as architectural patterns, okay. Now the other one here is a design pattern. So it all suggests a scheme for structuring the classes in design solution and defines the interactions among those classes, right? So here as part of design patterns, right, so actually you will be it is what it is actually a scheme for structuring the classes. That means how these classes can be how their how these classes can be uh, I mean, associated with each and the other classes, right? Each and every class is how each and every class is going to associate with the other classes, right? And their interactions, those things will be, part of these design patterns, right? So it all describes some commonly recurring structure of communicating classes that can be used to solve some general design problems, right? So you can think of always like, so you can find out, so in your design, so maybe you see that these are the different classes, should always communicate so as to solve a particular problem, okay. So then you will be applying those sort of communicating classes can be applied wherever you want. Okay, so that is what the idea, right? Are typically described in terms of classes and their instances and roles and collaborations. So here what we try to do, let's say you find that in any problem, let's say where you see that, so these are the classes and these many, these classes for which you should have these many number of instances, and their role should be like this, and they should collaborate in this way. Okay, their collaboration. So now if you identify them, so and if you know the solution for that particular problem, then you can apply the same sort of pattern wherever it comes, right? So now let's say, for example, we take an example to understand these patterns. Maybe you might be wondering what is talking about all these things. So we do not see any practical things, right? So it all looks like classes, and then they were so saying that some problems, common problems, right? And then solutions, and then which particular context these problems occur, and how this the solution, how this work in different contexts, right? So you may be looking at, so one, I will go by one example. So there are many other examples, right? So here one example is the factory method, right? In your C++, right? So there is a concept called factory method. So the factory methods are the ones they're going to create instances of different types. Okay, so they are going to create objects of different types. Okay, so now I will show you an example where there is no factory pattern, and then we will apply this factory pattern. So how we can make our code very efficient, that is what we are going to see, right? So I told you, so design patterns means what? You see some sort of problems, right, for which there is a known solution, and then this known solution will be applied wherever you find that sort of problem pattern. So you try to apply that particular solution, right? This is what exactly a pattern. So now one example here is a factory method, right? So now you understand, probably I do not I don't want to explain the basic things, right, as part of a C++, right? But you can understand here is a class. Okay, so it is a library class. Class means you have set of classes. Okay, you have set of classes, right? So library classes, right? So now here one class you have is a vehicle class. Okay, and now within this particular vehicle class there is a public method. Okay, or here it is a very pure virtual method. So why it is a pure virtual method? So the pure virtual methods are represented through equal to 0. Okay, if you do not use this equal to 0, then it is a virtual method, right? So they are usually used in the inheritance. Okay, so you will have to, whenever you say something like a virtual method, so usually if any of its derived class or the it's a subclass, so must implement this particular method. If that doesn't implement, then it is so it will throw you an error, right? So you can go through this concept, right? So now what I say you here is, so here there is a print vehicle, so it is going to print the vehicle type. Okay, this is the virtual method, right? Now you see, so it's a very simple class. Okay, you have a virtual method. Okay, pure method, right? Now there are two classes. One class is a two-wheeler and the other one is a four-wheeler. So the two-wheeler is extending, so trying to inherit the vehicle class. Okay, and within this particular class there is a print vehicle. So this print vehicle method is going to display what? I am two-wheeler. Okay, this is what? So this print vehicle is the method that is part of your vehicle class. Okay, so that is a pure virtual method, right? As a result, you must have to have implement that, right? So that is the reason why you have implemented it. Okay, so now how you implement it? You have just displayed something, I am two-wheeler, right? So now there is a class four-wheeler. Okay, so this is also extending the class vehicle and it is also printing, right? What it is printing? It is saying that I am four-wheeler. So now here there are two classes. One is two-wheeler, the other one is a four-wheeler class, right? Now so that is the library classes. Okay, Now there is a client class. Okay, let's say here we have a client class. Okay, now what a client class is going to do? So it has a very parameterized constructor, right? Int type. Now so through this int type, it is going to explicitly create an object of class two-wheeler or four-wheeler. Okay. If the type value is 1, if the type value that you are giving when you are going to create a object to this particular class, client class, right, you will be passing a type. When you pass the type as a 1, so what will happen? It will create a object to two-wheeler class, right? If the type is 2, then it is going to create an object to four-wheeler class. Now if none of these valued that this type may be other than this, then it is going to create so null pointer. That means it is not going to create any object, right? So the reference variable have null. Okay, so it is not pointing to any class objects. Okay, it is not pointing to any class objects, right? So this is the way that now you have a client class, right, understand? So your client class will take explicitly, right? So the type, and then accordingly it is going to create this instance, right? Now understand? So here is a destructor, so which is exactly going to handle this memory leaks, right? So it is going to free the memory leaks, memory whatever you have created, so that will be deleted. So it is to memory management things, right, as part of your destructor, right? So then you have a get vehicle, so which will actually tell you what is the vehicle, okay? And there is a private attribute. So here you have a pointer variable, right? Vehicle pointer variable, right? So this P vehicle, right? So this P vehicle is what exactly you do, right? So P vehicle is equal to new two-wheeler. That means you are going to create a instance and which is going to refer to a pointer type P vehicle, right? Which is the pointer vehicle P vehicle is going to refer to the new two-wheeler object. Okay, so that means through a new operator you create the objects, right? So this is what as part of C++, right, we do. Now there is a main program. This is the driver program, let's say. Okay, and through this program what you try to do here, so you create an instance to a new client, as I told you. So you passed a type of the vehicle. What is that here? 1. When you pass this, when you create this object, okay, so what will happen? So your constructor will be called like in a new client. So here the new client, so the client will be called. That means type is equal to 1 and it is going to create two-wheeler object. So it is going to create two-wheeler object, right? Now when you say P client get vehicle, what it is going to give you? It is going to give you the two-wheeler, right? And when you call this print vehicle, what it is going to print? It is going to print that I am a two-wheeler. Okay, it is going to print this, I am a two-wheeler, right? So now this is the simple program that we have created, right? Now so here we have not used factory methods, right? And what we did is now what is the problem here is now the pattern problem we need to identify here is what? So today, let's say we have these library classes. Okay. Now today you have these library classes, right? What library classes you have? So you have a two-wheeler and four-wheeler, right? Now what will happen? So tomorrow somebody wants to add three-wheeler instead of two-wheeler. So somebody wants to add three-wheeler. So when you add three-wheeler, that means you add another class here. So three-wheeler, then accordingly what you need to do? You need to is part of your client class also. Okay, so you have to make some changes. What changes? Now you have to write something here also, right? Type is equal to 3, then you will be able to create a new three-wheeler object, right? That means whenever you going to add some new class to the class library, so certainly you need to make some changes in the client class also. Now this is the class available with the client, okay, side. and you have developed some other classes, right? You have developed some classes, right? And you wanted to add them into the library. So when you add something, so you have to make here some certain changes, then only you will be able to address that particular, you can able to create a object to three-wheeler class. Okay, now so let's say if you add thousands of classes, then what will happen? So at the client class also you have to add thousand many number of conditions here, so as to you can create an object for that particular kind of class. Okay, and this is what happens, right? Now the problem here to understand. So now if you want to add more number of classes into the library class, certainly you need to make some changes in the code in the client class also. Now when you make some changes, what will happen? Again you will have to compile them. Now it is a very tedious task. It's a problem actually, right? Now how we will solve this sort of problem? Now we will see through a factory method, right? So that is what the idea. Okay, now the same program will be shown, but some changes are there. I will display you out those changes and then we'll stop. Now here we see what we are trying to use. So here we will use something called enumerator, right? Through which we will be we will have some constants, right? So you know that in C++ enumerators, right? So this particular BT underscore two-wheeler, this will take the value of 0, this will be assigned the value of 1, and this will be assigned the value of 2. So this is the way that automatically, so enumerator will assign some constant values to these terms, right? So keywords. So this is the way that you enumerator works. Now I have, what I did is, so here as part of this we have added one static method. Okay, we have added one static method apart from the existing code. Here this create static method is going to create instances of different types. Maybe it is going to create a two-wheeler, four-wheeler, three-wheeler, whatever the instance type you want, it can create. Okay, now then whether our problem solves or not, that we're going to see. So now here you see class two-wheeler, so which extends the public vehicle. Print vehicle is I'm two-wheeler, that is fine. Now this is similar, same as the previous program. Now so your the library class wants to add this particular new class. What? So here three-wheeler we want to add it on a later point of time. Okay, so then we have added this. So I am a three-wheeler now. Okay, and similarly you have a four-wheeler class already existing, right? Now what will happen? Now you see I created one static method. So the static methods are created like this, right? So vehicle and scope resolution create, right? And vehicle type. So whenever the vehicle type is passed to this create method, right? What is the type you will be sending? Because it is an enumerator, right? Vehicle type is an enumerator, right? If you say BT underscore two-wheeler, then the type will be checked here, and it is going to return what? A object to two-wheeler. Now if the type is equivalent to this, it is going to return three-wheeler object, four-wheeler, like this. Okay, now this is what we have written as part of what? Library classes only. Okay, we made changes, right? Now are we going to make anything in the client side? That is what we are going to see. Okay, now your client side, what we are doing is you have a constructor here, client side. Okay, now here we are explicitly creating the vehicle type, right? Now we have taken here what? BT three-wheeler, we wanted to create an object, right? As a result I have initialized this type, and then this type is passed to the create method, right? Now what is that? Now your create method so is going to create an instance to the three-wheeler, right? It is going to create the three-wheeler, right? So this is the way that you are going to create, right? Now you see, do you really need to write anything like if else kind of thing? No, it is not really required, those if else kind of thing. If you can add four-wheeler, five-wheeler, six-wheeler, seven-wheeler, whatever may be, but you can pass simply here. I mean through this, you can through an argument also, client argument also, you can pass the type of the wheeler, and that can automatically create an instance of this. Okay, so you no need to make any coding logics as part of the client side. Like there if else thing you made, right? Whenever you new class is added, so you have done. Here what you need to do, you have nothing to do, because to make you understand here I have written here initialize this three-wheeler, but even you can pass this through your client constructor only. Okay, you can pass this through client constructor. Okay, whatever you pass, though automatically, so you can create an object. That means you no need to make anything changes in the client side. So only you need to make whenever you wanted to add any new classes into the library, you keep on adding 10, 20, 30, 40, whatever may be. But while you are creating an object to this client, automatically will be able to create a instance of that. So that means it is what we call as a factory method. So factory methods are the ones which are usually used to create instances of different types. That is what we are trying to do. Now what is the REST client destructor is the same thing and everything is same, right? Now so what you will be doing here, you just writing the same program, right? Street client, you creating an object to a new client. That means this client constructor is called. So now that is initialized and automatically now the object is created. Okay. Now then you call the get vehicle. Now print vehicle. Now what will be the print vehicle display you here? Can anyone tell me what is the output here? What would be the output here if I run this program?
Three-wheelers.
Three-wheeler, because we call the get vehicle for the instance three-wheeler, right? So here output is three-wheeler, right? So now you see, so this is one sort of problem. Now it is not a something, it all comes with the experience, right? It all comes with the experience, right? So if you have no experience, then what you will do, you will follow the first mechanism without factory methods, right? You keep on adding if else this sort of. Okay, whenever there are new classes added, so at the client side also you keep on adding this if else, right? And which will require different times you need to compile the programs, the client side also. So when you added a new class in the library class, at the same time you need to add here. Now it's a problem, right? This is what a problem. For this problem, what is the pattern? So factory method sort of thing is a pattern solution, right? So do you understand? Any doubts so far? So if you have identified these sort of problems, so now these problems will be, created, and these can be applied whenever you are required. So I told you that this is what exactly a design pattern. Now there is a idioms. Okay, so idioms are the low level patterns. Okay, so that are programming language specific. Now so it is all related to programming language specific. Okay, it's not related to logic. So here you have a logic, right? So it is not related to the factory method is not related to the programming language. Okay, so it is your idea of how better way you can write your code. So as a result, it is going to give you good efficient design, right? So you will be able to write a efficient code, right? But here it is low level patterns that are related to programming language specific. Okay, you can understand idioms are what in simple English, what we call idioms. So let's say you have three different dogs are barking. Okay, dogs are barking at the tree or something like this. If you have something, so what you do, so whenever you dogs is one meaning, barking is one meaning, tree is one meaning, right? Now when you combine these are three things, right, they have one meaning, right? And this meaning is already created. Dogs are barking at the tree. Okay, so that means that has a meaning, right? So whenever you wanted to use this particular idiom in English, what you will do, you will not think about that what it is, because you know that dogs are barking means you have some meaning in your mind, right? So if you think that yeah, dogs and barking and then tree, so if you try to create meaning and all, it will take a lot of time, right? Do you understand? So if you have certain idioms, so what you will do, without thinking much about that, you can write a sentence, okay, quickly. Do you understand? Let's say somebody has something this sort of thing, right? So uh, prevention is better than cure. Okay, if you know this, so what you do, you can, when you are writing something, wherever you want this sort of thing that you want to write, so without thinking much about this sentence creation, so you will write this. You know why? Because this is already a solution created by somebody. Okay, so this is the solution there, this is the pattern there, now you can use it. Okay, so you can use it, right? So these are the idioms, right? So similarly in your programming language also you will have something like this. Describe how to implement a solution to a particular problem using the features of a given programming language. So it is all related to the feature of the programming language. So how better way you can use the feature of that particular programming language without thinking much. So that is what exactly. Okay, so that will also improving the quality of code. So when you going through these all idioms usually, so you see the reduced number of errors, as well as no need to go through the corrections for iterations. So right, so usually you can compare like what is the difference between algorithms and the patterns. So patterns are more concerned with the aspects such as a maintainability and the ease of development, rather than when you talk about algorithms, what happen, you need to tell that how efficient my algorithm is, like in terms of space and time. I mean, how better in terms of time complexity and space complexity. But here patterns are more concerned with the aspects of maintainability, how you can maintain your code easily, how you can, how your development will be easier. So that is what, right? So this is what exactly all about the design patterns, right? So we'll talk about, we will try to continue from here after in the next lecture. Okay, maybe tomorrow. So tomorrow 10 o'clock, right? I told you.
Yes, sir.
Yes, sir.
Okay, so now I stop the recording, right? If you have any doubt, ask me now quickly.